dm cubed as the volume. Now, to do this question, we have to do it in two parts. So first, as soon as they tell us this bit over here, there is an equation which is moles is equal to volume over 24 dm cubed. Now, they want us to calculate the volume of oxygen. So we need to rearrange this equation, but before we do that, we need to calculate the moles. Now, we don't have the moles of oxygen. And to calculate moles, there's another equation, which is moles is equal to mass over mR. Now, as you can see, we don't have the mass of oxygen, but we do have the mass of aluminium. So what we'll do is we'll just basically do it in ratios. So let's just start it off simply. So let's calculate the moles of aluminium. So the moles of aluminium is the mass, which they give us 1 kg, and to convert that to grams, it will be 1,000 grams. And then we divide that by the mR, the relative atomic mass of aluminium. And as you can see on the periodic table, the mR for aluminium is 27. So once we do that, like that. However, as you can see, we have 4 aluminiums, 4 moles. So what we'll do is we'll do 27 times by 4. Now, when you do this, you should get an answer of 9.259. Now, coming back to this equation over here. As you can see in the equation and the question, they say 1 mole of gas has a volume of 24 dm cubed. Now, if we look at oxygen in this question, we have how many moles? We have 3 moles. So, if we write this out again, moles is equal to volume over 24. For every 1 mole is 24, but in the question, we have 3 moles of oxygen. So, we'll do 24 times by 3. Now, if we write this again, with the moles, we figured out the moles is 9.259. Now we can use that for the oxygen. So let's write 9.259 is equal to volume over 72. Now we just need to rearrange it. So we times it, but on both sides, that will cancel. So we're left with 9.259 times by 72 is equal to the volume. Now volume is equal to 6 on your calculator, it should be 666.648, which will then give us an answer of 667.